Hello friends, welcome back to my YouTube channel. So in today's video, we'll see the degree of kinematic indeterminacy for trusses. So in previous video, we have seen the degree of kinematic indeterminacy for beams. So we have solved by considering the axial deformation as well as neglecting the axial deformation. So in today's video, we will see the degree of kinematic indeterminacy for trusses. So if you remember, so how many equations are there at a joint to solve the, so if you remember, to solve the trusses at any joint, to take this or this, there is always two equations are there to solve any joint. That is, I will show you, summation of fy and summation of fx. So there is no moment in case of trusses. So at any joint, if you take, to solve this joint, there is only two equations. One is vertical and another is horizontal. So in case of trusses, we always consider the axial deformation. Here we should not neglect the axial deformation. So we'll see. So in our problem 2j is there. It means, I'll show, to solve any joint, there is two equation. One is axial deformation, is also called as the horizontal deformation, and vertical deformation. In case of trusses, there is no moment exist. So that's why in 2j means, j means at any joint we have two equation. One is axial, another is vertical. That's why the formula is 2 into j, and minus r is the number of unknowns and j is the number of joints. So we have only two equations to solve any joint. That is, one is vertical, another is horizontal. So what degree of freedom says at any joint in a truss how much it can deform. The possible ways of deformation is only two. One is vertical, another is horizontal. So we'll see here. So at roller, how many reactions are there? Only vertical reaction is there. But at any joint, if you take this joint, how many possible deformation is two? One is, wait, I'll show. So the possible deformation is, one is vertical, one is horizontal, and another is vertical. So in reaction, vertical reaction is there, and in deformation of also the vertical deformation is there. So both will get cancelled with each other. So only remaining as one horizontal deformation is there. So at dk at this joint is 1. So here at hinge, how many reactions are there? One is vertical, another is horizontal reaction is there. So but at this joint, the deformation is horizontal one and vertical one. And the vertical, here also vertical reaction is there and vertical deformation is there. Both will get cancelled with each other. And the horizontal deformation is there and horizontal reaction is there. Both will get cancelled with each other. So degree of freedom at hinge support is 0. So at roller is 1, because here the horizontal deformation will exist. So in case of roller, there is no horizontal reaction. So dk at roller support is 1. So at this joint, the possible deformation is 2. One is vertical, one is horizontal. So dk at this joint is 1. Dk at this joint is 2. So add it to 1 plus 1, 2. So dk at this structure will come out as 2. So if you calculate by using this formula, we'll see the answer. The how many joints? 1, 2, 3. Number of joints are 3. So how many unknowns? Number of unknowns is nothing but reactions. Here 1, here 2. Total 3. So substitute in this formula. Formula 2 into j is 3 minus r is 3. 2 into 3, 6. 6 minus 3. 6 minus 3 is 3. So here also 1 plus 2 is 3, not 2. dk will come out as 3, not 2. So both the answer will same. So it make it as 3, not 2. Here one at roller support our dk value is 1, and at this joint our dk value is 2. So 2 plus 1 is 3. Make it as 2. Make it as 3, not 2. So when we calculate by using this formula, our answer is getting 3, and if you do manually, our answer will we got as 3. So both the answer will same. You can go through this formula, or you can calculate by simply remembering these values. Manual also you can calculate. So I will write here dk at roller. At roller support, one reaction is there, that is vertical. At this joint, how many the possible deformation is? One is horizontal, another is vertical. So vertical will get cancelled. The remaining value is our dk is 1 at roller support. If you take the hinge, how many reactions are there? 1, 2, one horizontal and one vertical. The formation of deformation, the possible deformation, one is horizontal and one is vertical. So horizontal will get cancelled and vertical will get cancelled. dk value at in support is 0. So we'll see some problems. So this is the one structure. We can calculate first by using formula. How many joints are there? 1, 2, 3, 4, 5, 6. 6 joints are there. So number of joints are 6. How many unknowns? Reactions are in support 2, at roller 1. There will be one reaction here. One is horizontal and another is vertical. 2 reaction. Total numbers of unknowns are 3. So now substitute in our formula. Formula is dk is equal to 2j minus r. 2 is how much? 2 into j is 6 minus r is 3. So 2 into 6 is 12 minus 3. So 12 minus 3 is 9. Our dk will come out as 9. So now this is one structure. So how many numbers of joints? 1, 2, 3, 4, 5, 6. Number of joints are 6. And how many unknowns? At hinge 2 reaction, horizontal and vertical, and at roller only 1. So number of reactions are 3. Now substitute in our formula. dk is equal to 2 into 6 minus 3. So 2 into 6, 12 minus 3, 12 minus 3 is 9. Our dk will come out as 9. So we'll see one more problem. So how many joints are there? 1, 2, 3, 4, 5, 6. Number of joints are 6. So how many unknowns? At hinge 2, one is horizontal, one is vertical, another is horizontal. At roller only one reaction will come, that is vertical. Total numbers of unknowns are 3. Now substitute in our formula. dk is equal to 2 into j is 6 minus r is 3. 2 into 6, 12 minus 3. 12 minus 3, 9. It will come out as 9. So we'll go with this. So how many joints are there? 1, 2, 3, 4, 5, 6, 7, 8. Number of joints are 8. So number of joints are 8. The how many reactions? Here roller 1, here also roller. The vertical reaction takes place. The number of unknowns are only 2 here. Substitute in your formula. dk is equal to 2 into j is 8 minus r is 2. 8 into 2, 16. 16 minus 2. Answer will come out as 14. Now we'll see. So we'll see. So at roller, here roller one reaction takes place at inch, one is vertical, another is horizontal. So now how many joints? 1, 2, 3, 4, 5, 6. 6. And how many reactions? 1, 2, 3. So write it in our formula. dk is equal to 2 into 6j. 6 minus 3. 6 into 2, 12. 12 minus 3, again it will come out as 9. So dk is 9. This is how we calculate by using the formula. Now we will see manually without using the formula. What I have said. So what I have said, at any joint the possible deformation is only two. One is axial, another is vertical. So at this joint, one is horizontal deformation, vertical. So at this reaction, at this support, the roller support is connected. At roller support only one reaction takes place, that is vertical. Here also vertical reaction is there. Here also vertical deformation is there. So both will get cancelled. So the remaining is only 1. So dk at this joint is 1. So here on joint is there, one is vertical, another is horizontal. Here also vertical, horizontal. Here also vertical, horizontal. At here, look at here, this joint, one is horizontal, another is vertical. So at this support, the vertical as well as the horizontal reaction is there. So vertical and vertical deformation will cancel, and horizontal reaction and horizontal deformation will get cancelled. The remaining is 0. The decay at the joint is 0. So if you come to this joint, again horizontal and vertical deformation is there. So remaining how many numbers of decay? At this support 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total number of degree of freedom as this structure is 9. So if you calculate manually, our answer we got as 9. So our answer is same when you calculate by using this formula as well as by manually. So we'll move to next structure. So this is one truss. The in support have the two reactions, and here also one horizontal and one vertical deformation will take place. So horizontal reaction and horizontal deformation will get cancelled, and vertical reaction and vertical deformation will get cancelled. At fixed, our dk value is at in support our dk value is 0. So at this joint, the formation of vertical as well as horizontal. Here also one vertical, one horizontal. Here also one vertical, one horizontal. Here also one vertical, one horizontal. But this support has the roller support. It means it has the one reaction, that is vertical. So here also vertical deformation is there. Both will get cancelled with each other. The remaining decay at this support is 1. At this joints vertical and horizontal. So total how many degree of freedoms are there at the structures? Here 0, 2, 2, 4, 6, here 1, 7, 8, 9. So total number of decay at the structure is 9. So we'll move to next structure. This is a truss having one hinge and another roller. So at hinge, as usual, horizontal and vertical deformation will take place. Here also vertical reaction is there and vertical deformation is there. Both will get cancelled with each other. And horizontal reaction is there and horizontal deformation is there. Both will get cancelled with each other. So decay at this support is 0. So this joint has two deformation. One is horizontal and vertical. So here also horizontal, vertical. Here also horizontal, vertical. But the roller support vertical reaction is there. Here vertical deformation is there. Both will get cancelled with each other. The only horizontal deformation is there. So degree of freedom at this support is 1. And at this joint again 2. Horizontal and vertical deformation at this joint also. Horizontal and vertical. deformation is there. So total how many numbers of degree of freedoms are there at this structure? Let's count. Here 0, here 2 plus 2 4, 4 plus 1 5, 5 plus 2 7, 7 plus 2 9. So DKI at this support is again 9. So our answer is also 9. So both will same. Now we'll see. So at this structure, so both end connected to the roller. So one our horizontal deformation and vertical reaction is there. Here also vertical reaction is there and vertical deformation is there. Both will cancel it with each other. The only one deformation is there, that is horizontal. So at this joint again two numbers of horizontal vertical. So horizontal vertical here also. So vertical horizontal vertical horizontal, here also horizontal vertical. Here one vertical reaction is there and vertical deformation is, both will get cancel each other. Degree of freedom at the joint is 1. Here also 2. Here also 2. So total how many degree of freedom are there at the structures? So 1, 2, 3, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, 9 plus 1 10, 10 plus 2 12, 12 plus 4 14. So total numbers of degree of freedom at this structure is 14. So when we calculate by using the formula, we got our answer as 14. So both will same. So we'll move to next structure. So if you take the structure air roller, two deformation will take place, horizontal vertical. So here also one vertical reaction is there, vertical deformation is there, both will get cancelled with each other. At roller only one degree of freedom is 1. So at this joint 2. At hinge degree of freedom is 2. One is horizontal and vertical deformation is there at this joint. At hinge two reactions takes place, vertical and horizontal. Here also vertical and horizontal. So vertical reaction, vertical deformation will get cancel each other, and horizontal deformation and horizontal reaction will get cancelled with each other. At in support the DK value is 0. So at joint one is vertical, another is horizontal. Here vertical horizontal, vertical horizontal. So total how many numbers of first 1, 1 plus 2 3, 3 plus 2 5, 5 plus 2 7, 7 plus 1 8, 7 plus 2 9. So DK at this structure is 9. So this is how we calculate manually without the help of the formula. This is how we calculate the degree of freedom for trusses by using the formula as well as manually. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.